Hello everyone, good evening. I am C. Harshavardhan. I am from Triple Department, A section, subject Engineering Physics, topic Direct and Indirect of Band Gap of Semiconductor. Introduction to Direct and Indirect Band Gap Semiconductor. Band gap is the energy difference between the valence band and the conduction band in a semiconductor. Direct band gap semiconductors have a direct transition between the valence and conduction bands. Indirect band gap semiconductors have an indirect transition between the valence and conduction bands. To observe the diagram of a direct and indirect band gap. Properties of direct bandgap of semiconductor. Direct bandgap semiconductors have a shorter recombination time, resulting in faster emission of photons. They have a higher probability of radiative recombination, making them suitable for light emitting devices like LEDs. Direct bandgap semiconductors are efficient in absorbing and emitting light, allowing for high performance photovoltaic applications. Definition of indirect bandgap semiconductor. In an indirect bandgap of semiconductor, the maximum energy of the valence band and the minimum energy of the conduction band occur at a different momentum. Indirect bandgap semiconductors have a lower absorption coefficient, making them less efficient in optoelectronic devices. Example of indirect bandgap semiconductors include SiGe and GAP. Properties of indirect bandgap of semiconductors. Indirect bandgap semiconductors have a longer recombination time, resulting in slower motion of photons. They have a slower probability of radiative recombination, making them less suitable of light emitting devices like LEDs. Indirect bandgap semiconductors are less efficient in absorbing and emitting light, limiting the use in photovoltaic applications. Band gap energy. Band gap engineering involves modifying the energy band gap of a semiconductor material. Direct band gap semiconductors can be engineered by allowing or introducing strain to modify the energy levels. Indirect band gap semiconductors can be engineered to become direct band gap by reducing the momentum difference between the valence and conduction bands. Applications of direct bandgap semiconductors. Direct bandgap semiconductors are commonly used in optoelectronic devices like lasers and LEDs. They are also used in solar cells to efficiently absorb and convert the light energy into electrical energy. Direct bandgap semiconductors find applications in telecommunications, optical sensors, and high-speed electronics. Applications of indirect bandgap semiconductor. Indirect bandgap semiconductors are mainly used in electronic devices like transistors and integrating circuits. They are also used in photo detectors and thermal imaging devices. Direct bandgap semiconductors are widely used in manufacturing of computer chips and microprocessors. Comparison between direct and indirect bandgap semiconductor. Direct bandgap semiconductor have a higher absorption coefficient, faster emission of photons, and are efficient in optoelectronic devices. Indirect bandgap semiconductors have a lower absorption coefficient, slower emission of photons, and are mainly used in electric devices. The choose between direct and indirect bandgap semiconductors depends on the specific application requirements. To observe the diagram of the comparison between direct and indirect bandgap semiconductor. Conclusion. Direct and indirect bandgap semiconductors have distinct properties and applications. Direct bandgap semiconductors are efficient in optoelectronic devices and photovoltaic applications. Indirect bandgap semiconductors find application in electronic devices and chip manufacturing. Thank you.